Okay, let's now go through your homework questions for practice 4A. So in practice 4A, you are given a shape, a quadrilateral ABCD, and you are given, some sides that are the same. So you're told that DE, is equals to CE, and AE is equals to BE, and you're given some angles over here. So in part A, you are asked which triangle is congruent to triangle BEC. Okay, so if we look at the triangle, let's do this out here. Okay, let me just make this smaller. Alright, we want to look at triangle BEC. So BEC, this triangle here. Okay, so by intuition, you should be able to see that BEC will correspond to this triangle on the other side here. Okay, but besides this, even though the question doesn't ask you to prove, you should prove that the congruency. So we can say that this is actually congruent to, well, you know that B should correspond to side point A, and E will correspond to the point E, and C will correspond to the point D. And we actually have to prove this. So let's prove it. How? You'll find that, well, these two triangles have two common sides. I cannot assume the third side is equal, so I cannot use triple S. Then the next one I think of is, can I use SAS? Now to use SAS, I need to prove that the two angle E's are actually equal. Am I able to prove that? I'm able to prove that because these two angles are actually vertically opposite angles. So if I start off with my proof, I can actually prove that BE is equals to correspondingly AE. This is given. So this is your first S. Then we try to use the angle in between, angle BEC. Angle BEC is equals to angle AED. And why is this so? Because they are vertically opposite angles. So this gives you the A. And finally, the last side, I have ED, or rather EC is equals to ED. And this gives you the second side. So you can prove that triangle BEC is congruent to triangle AED by SAS. So even though the question doesn't need you to prove, it is good to show. Next, part B. We want to find the triangle that is congruent to triangle BCD. So let me use a different color to highlight triangle. Now we are looking at triangle BCD. Let's look at triangle BCD here. Alright, what do we know about triangle BCD? Well, let's see what we can find. We will probably suspect that triangle BCD is actually congruent to this other triangle here, ADC. But how do we actually prove that? Let's try and work through our series of tests. First of all, can we show using SSS? Not likely because we only know that it has a pair of common sides. But maybe we can show using SSS, because, well, let's say, our hypothesis is that this is congruent to triangle. We know B is likely to correspond to A. C in this triangle BCD is likely correspond to D. And D of this triangle is likely to correspond to ADC. So let's test this hypothesis out. So if we use triple S, that means that we need to show that all the three sides are equal. Well, the easiest one is CD is equals to DC, right? Because they are actually the same side. So we can write it as common side, and this gives you the same side. Now, then we can also show that, the triangle BCD, BCD over here, DB is actually equals to CA. Why? Because DB is made up of, DE and ED, which is the same as over here. You see these two common sides here. This side is the same as this side. This side is the same as this side. So the lengths are actually equal. So this gives us the two second common side. And then, can we prove that, okay, the last side that we need to prove then is, okay, look at triangle BCD. We need to prove this side here, right? Can we prove that BC is equals to AD? Okay, can we prove that BC is equals to AD? We can, because actually just now when we look at triangle BEC and triangle AED in part A, right, we already know that these two triangles are congruent. Therefore, AD must be equals to BC. So this is because triangle, okay, we use our part A here, triangle BEC is congruent to triangle AED. Therefore, we know that BC must be equals to AD, and this gives us the last side. Therefore, we can prove that triangle BCD is congruent to triangle ABC by the side test. Okay, so these are the two proofs of congruency. Now then, the last part, okay, you are given some dimensions here and you are asked to find BD. Okay, so BD, okay, we know that this is 9.8, this is 6, sorry, this is not clear. Okay, so if this side is 6, if this AE is 9.8, we know that EB, okay, is also 9.8 because of the two congruent triangles. Therefore, in C part 1, if I want to find BD, okay, BD, look over here, BD is just 6 plus 9.8. Okay, so BD is 6 plus 9.8 and you get 15.8 cm. Okay, next you want to find angle BCE. So let's go back and look at the diagram, angle BCE, okay, this angle here. Now this angle here, okay, would actually, alright, be found if we can find this angle over here. Because we have this is 34, okay, if we have this angle here, we can use angle sum of triangle. Now, how do we find angle BEC? Now, you notice that angle DEC is 100 degrees, right? And BD is a straight line. So, I know angle, okay, so before I find this, we know that angle BEC is equals to 180 degrees minus 100 degrees. And this is because of adjacent angle on a straight line. And therefore, angle BEC is 80 degrees. Okay, refer to the own diagram in the textbook, it's easier. And therefore, angle BCE is just equals to 180 degrees minus 80 degrees minus 34 degrees. The reason being I'm using angle sum of triangles. And this gives you 100 minus 34, which is 66 degrees. Okay, so you get the answer for angle BCE.